Okay, hello, welcome again at this part 2 of the Mario Bros. Valve Madness, as I have called it. It's an impossible name to pronounce in the original Advent of Code, but here we are again. Advent of Code 2022, day 16 with Mario Bros. Where were we last time? We talked about the second part already, and the second part talks about having a new player into the field who can do the opening of the valves for you. The new player is an elephant. Okay, you need 4 minutes to instruct the elephant how to open the valves, and after that you got like 2 players in the field. By the way, it is now Valentine's Day. It's the 14th of February. We have just finished the amazing Italian song contest, Sanremo. So we can put that back again and we go ahead with our Mario Bros. And as always, we solve these Advent of Code puzzles with Progess OpenEdge. So coffee is ready and let's go. Multiplayer, how can we do it? Well, basically I found 2 approaches to this situation. The first one I took was to do brute force. I said, okay, let's divide the valves, the open valves, between one and another player. So we get how many states do we have, open states of open valves. And we divide it by 2. So okay, let's give the one part to the first player and another part to the second player. Give them 26 minutes and have them solve the situation. See what gets the maximum value of combination of open and closed valves. That was like a brute force approach. And the second approach is the, as I call it, keep on walking. Which means that once the first player runs out of time, there's no more time left to solve any more, to open any more valves. We check if there is another player, and if there is another player, we continue the search path, but with the second player that has the situation of the open valves from the first player, but starts again from the starting point AA with 26 minutes of time to do his part of the puzzle. Okay. So, for the divide and conquer, we need to know how many states we have. There's 2 up to the number of valves. And in our situation, we have like 2 to the 15th, if I'm right. So 32,000 possible states. So yeah, that makes it a little bit longer. Remember, the first part took like 17 seconds. The second part will be much longer with this approach, but okay, it is a simple approach. We only need to do this part of the program. We just go through a value of all the open states divided by 2, because it doesn't make sense to invert the 2 surges, because they will give the same result. So we stop at the half, and we determine what are the open valves in the first situation. So the left switches based on how many open valves we have, and in the second part, the other player will do the remaining part, which is like the maximum minus what we have already opened minus 1. And in order to find the solution, we just give the 2 runs and get max flow starting from AA with 26 minutes with the open list of the left side, and we add that to the get max flow from AA 26 minutes and with the open valves from the right side. So we have the 2 players, one is left, one is right, and we just have them run. And that goes on for like 16,000 times. Okay. We need 2 helper functions. I can show you some of the code. let's go to the code. We have our nice development environment, and the get binary function is basically a function to have the to have a number returned as a string of bytes, of bits, sorry. So 0 and 1. And where's my mouse? My mouse is gone. Here we are. Okay. So let's get into this part of the code. I have put it into the scratchpad. The get binary function. So this is the get binary function. As you can see, I just put in an integer, which is the value to turn into a string, and the length, because I need to know how many bits you want. And if I try this simple function, I want to test it. I just define a integer value as an integer 64, and another integer for the length, how many bits I want. And then to do some testing, I just update the value of the to transform label value, and I specify the length I want in bits, length in bits, and I display, sorry, I'm mixing up the letters, sorry for that, and I display whatever result that comes from the get binary, passing in the value and the length. So format as a character, let's give it a lot of characters, like 30, and this is the binary string. Okay, now let's see what happens. We just run this program, run the program. Okay, he will ask me for a number, let's say 1, and how many bits you want, let's say 4 bits. Now that turns into be 0001. Okay, so we can count binary 2, 3, 4, 5, and as you can see, this is basically the way a number is transformed into a bit string. But what happens when I say 7 and 8, 9, 10, 11, 12, I can think you can see the problem coming. 14, 15, now what about 16? I've asked for 16 in 4 bits, that is not possible. So I get a wrong answer. Oops, that is a bug. Let me solve this bug. The solution could be, say, okay, if there is still something left, then maybe we didn't have enough, so we didn't have enough bits, so we run the same. So if it's greater than 0, then we have a problem, and we return the get binary for the original input, so we have to save that original input. Let's call it input. Okay, and before we start in this loop, we can set it to the input value we got in 64. Okay, and so we give the original input, but this time with a length of 1 more than we had. So the length plus 1 should be enough. If it's not enough, then we will again fall again into the this if, and just do another run with a more length. So if we try it like this, run, what do we see? Let's call this 15 in 4 bits, that is okay. 16 in 4 bits, okay, perfect, that becomes 5 bits. So if I have 32, 7, 8 in 4 bits, it will automatically say, no, that's not enough, I will give you more bits. And that works better. Okay, so small bug there, but easy to solve. So we can just copy this function back again to our source program, and you will find it in my repository later today. Okay, so that is one of the helper functions. Another helper function is how to transform this bit string into open valves. and I've had a small function for that as well. The get open list. Let's look at the code where that is. Okay, get open list. Basically, it says, okay, for each valve where the valve rate is greater than 0, by the valve in alphabetical order. The position is the position plus 1. If the substring in the input switches of this position for a length of 1 equals 1, then it was open. So in the open list, we just put the new valve at the end. So this is a function to turn this bit string into a list of open valves. We know that we have this bit string for other values as well. Here we have the same approach for each valve where the flow rate is greater than 0 by the valve code. And here the switches is composed of zeros and 1. If it's inside the open list, if it's not inside the open list, then we put a 0, otherwise we put a 1. So the get switches will give us back a nice binary representation of the open and closed switches in our situation. Okay, so back to the presentation. After the two helper functions, we can now do the run of the divide and conquer. And yes, as expected, it took a while. It took like more than 40 minutes. Anyway, it was way too long to win a prize. Let's look at the other approach. I have called this the keep on walking. In this keep on walking, I have a new get max flow version. It's called get max flow multiplayer, and I say an extra parameter that indicates the number of extra players I have. So I have one extra player at the start, and what happens is if the first one runs out of time, so you have time left goes under 0, then I say, okay, if I have another player left, then I can continue, can keep on walking. With the 26 minute starting from AA, I also have the situation of the open valves, which I go as a start position for this one, for the next run, for the keep on walking. And yeah, the thing is that people try to do this walking simultaneously. I go that way, elephant goes that way, but in the end it turns out that they can basically do the same thing one after another, finding if the second one comes in, he finds an already open situation, and all the possible situations are evaluated, and from every starting position you have another 26 minutes to go through the second part with the second player. So that is basically the eye opener, the mind opener that you should have seen to be able to solve it in that way. Okay, let's look at the code. We have a new get max flow multiplayer, and that has an additional parameter. The same additional parameter is also added to the TT visited temp table, so we can check if we have already evaluated a specific situation, including also if you have 0 or 1 extra players. And so once you run out of time, you check if there's another player, and you can continue the search if there is one. There are some code differences. So the original function is like on the left side, the modified function on the right side. We have an extra input parameters, and we have also this other players in the comment. Now what happens is that we have to TT visit it, and we have to include the number of other players in this temp table and in the search. If we find this situation already done, then we return the value that we found the first time. Then when the player goes out of time, so the time left, the new time left is the time left I had before, minus the minutes I need to get to the next valve, minus 1 minute to open that next valve. If the time left is less or equal to 0, then in the first version I just continued my search not going any further. But in this second part, I can maybe other players, if there is one other player or is greater than 0, I say, okay, now we can just continue by evaluating the values, the max value I've had so far, with a new run, get the max flow multiplayer starting from AA, another 26 minutes with the open list already established and with one less extra player. So this will only work the first time, and the second time you have no time left. It just goes into the next. Okay, as you can see, the call for the recursive call has also the other parameter, but nothing more than that. And once we have the value for this specific situation, we save it in the tt-visited temp table, including also the key of another player, how many other players we have. Okay, well, that was much better. So the runtime for Keep on Walking is 20 minutes only. So in less than half of the time, this approach is very much better, and the Keep on Walking is definitely the way to go. Okay, so what's the conclusion? Well, the day 16 was definitely a tough day, especially because many people, me included, we tried to look for a solution of the second part, which was not very easy to find. Brute force in OpenEdge is not really the best language to do this many calculations, but we love OpenEdge, so we're proud of having it done in the Progess OpenEdge. Anyway, by another approach, the Keep on Walking approach, we kept the times in a reasonable measure. Like 20 minutes is not that much for solving one of the toughest advent of code days. Okay, so what's next? Well, I have solved all the puzzles, and among them another tough day was day 19. As you can see the purple points, which indicate how much it took for the first 100 people to solve the part 1 of a specific day. So as you can see, 16 part 1 was solved quite fast, but after that it took an hour for the top player to solve part 2. Another tough day was day 19. It's called Not Enough Minerals, where you have to build robots with some sort of a recipe, and the robots build minerals, and you have to find the maximum number of minerals. So there's also a search problem. Day 22 was tough, but was tough because you had to use some extra tools. This was my tool. As you can see, it is a cube, because you basically had a map with a grid, and you had to go there. But at a certain point, at part 2, you were given the information that this map really was a cube. So instead of walking through one direction, now you had to find out, if you go off the edge of one part of the cube, where do you come? And that was the best way to implement that was by looking at the cube and see how one row column would go over into another row column if you continue in that direction. But if you're interested, write it in the comments that you would like to see the implementation of day 22, and I will make an explainer video for that as well. Another interesting day was day 17. As you can see, those are the highest and more difficult problems in this edition of the Advent of Code. In day 17 you had to play Tetris. You remember the game on the arcades. Basically you have different kind of blocks, like a square block, 2 by 2, or a long block, 4 blocks, and they fall down and they are moved by the wind in this case, and you had to establish where they fall down, if they go all the way down or if they get stuck on another block, and if they are stuck on another block, then next one comes in, and you had to find out what height it would be after, I don't know, 100 drops of different blocks. That was a nice one too to implement, and if you want that, write it in the comments. Obviously, any other day you want, you can write it in the comments as well. Yeah, I think the most difficult ones were these 4 that I mentioned. Okay, so please interact. If you want, like my video, subscribe to the channel and activate the notification ding-ling-ling, so every time a new video comes you will get a notification. And you can even buy me a coffee. You can go to buymeacoffee.com. The link is in the description. Thank you very much for your attention. See you soon in the advent of code with Progess OpenEdge.